No, we don't hear you yet.
Hello, can you hear me?
Yeah, now we can.
Yep.
Cool. This time Chen still cannot make this meeting. So, in last week, we finally the Crimson OD finally can survive the CBD test, and I think then because currently the safe build job only builds the task, only build the change that push to the CI repo, but that does not include the master branch. So the next thing I'm gonna to do is to include the master branch when building Crimson flavor, and then once it gets done, I will push the perf test exercising Crimson D to repo, so it will be run regularly along with other Redis Redis test suites. And after that, I will talk to Alfredo to add an API to Popito, so we can use the test result from master as a baseline when testing the PR. In fact, involving Crimson, and that's a plan. And that's pretty much I have. Videk.
Hello. First of all, the very unplanned thing. Last Sunday, I was informed I need to be in Netherlands on the day to give a talk about Crimson OSD. It was an emergency replacement for one of our colleagues who was not able to make the flight. Well, actually, it's funny, none of four flights I had was according to schedule. All of them was cancelled, rebooked, or delayed, even multiple times. I managed to stuck not only at the airport, also on the board during unboarding, because in some cases, because in Munich, on board, well, all ground operations were cased for some time because of thunderstorm. Crazy, but finally I extended our slides. Was exercising the talk to give us a smooth one, and finally made it. I hope that Mike Perez is happy. However, the entire burden had postponed a bit the other things. I'm discussing last week. I was discussing buffer factory concept with Avi. It looks promised. SeaStor folks are really emphasizing uniformity, even uniformity of behavior. They went to the DPDK. They want to the factory to be obligatory for all network stacks. Avi also proposed a very reasonable idea to treat the factory as one of options for the listen call. Anyway, I had to postpone the finishing the stack. I informed Avi in private about the emergency trip to Netherlands. Also, a bunch of reviews, but I need to get back to Crimson and finally make the CI seed integration. That's all from my side.
Redoc, is that discussion happening in mail list or elsewhere?
On SeaStor Dev, on mailing list.
Okay.
So Redoc, did you made it speak at the Netherlands?
Yes, finally,
Okay.
yes.
Okay.
It was crazy, but it was made.
Okay, cool. And Ronan, how's it going?
Okay. As usual, I mostly have questions for you from what I learned this week. One thing I glanced over what you wrote, Refu, regarding boost outcome. I just read it a few minutes before the talk, this talk, but I'm really for it. I introduced boost outcome into Indigo code in HP, and I really like the design of it. I think it's a better expected than better than STD expected, and very convenient if you want to avoid exceptions. So I didn't have time to think of all the details in what you wrote. Probably write something back, but I'm really all for it, for using it. That's one thing. The other one is a question. I know I just this week learned and understood class objects. Our store procedures.
Yes, in Rados.
Yeah, and I'm trying to understand what are our plans. I noticed that one of the tasks is just let's implement what's required for RGW, right? Or was it RGW? To implement a subset. Yeah, to implement a subset directly. Okay, that I understand. We can do it. We can write it in SeaStor. But how do we tackle the whole issue of this outside code that is going to run?
Well, so it's not really outside code. Like the RBD team is a Ceph team, right? It's a Ceph project.
No,
so it's
no,
not.
Yeah,
it's not that.
yes.
So it's that. In other words, it's not that it's difficult for us to create an object class like thing in Crimson. It's just that the exact same code won't work because it has some assumptions about the API it's given, right? Namely, that when it asks for a read, that read will return to that very same stack frame without going away. That's the entirety of the problem. So our choices are either hack around it, either using something exotic like set jump, long jump kind of stack switching tricks to leave that stack where it is and come back to it later, or we just decide that there isn't that much class code in the first place, so we'll simply port it, right, to whatever we decide we want the interface to look like. So those are it seems to be those are the options on the table.
Let me try to clarify what I'm asking. If you're talking about RDB code or whatever code that is part of the Ceph team, okay, we can handle that.
That's all of it, though. There isn't any external code.
But we are proposing. I saw the lectures. I see the documentation. We are proposing that our customers use this.
Yeah. So if anyone actually does, it'll become a stable interface. But right now, as far as I know, the only I could be wrong, but the only external user I'm aware of is a research group out at UC Santa Cruz that's using it to do some clever stuff with the MDS, and their stuff is written in Lua. So actually, what they created is a Lua interpreter class that interprets Lua code on top of the object class interface. And that's no problem for us because Lua is really easy to suspend a running stack and run it later. So we actually don't even have to modify their code, right? So at that level, it's no problem.
How do we handle every line of possible Lua or C++ code that blocks?
We don't.
That will block.
We don't. We create a new interface, and if it turns out there is code in the wild, hopefully they'll tell us, and they'll have to do a little bit of porting. But the code doesn't tend to be that complicated, and if it does turn out to be a real, live, genuine, honest-to-God problem, then we'll figure something out. But my guess is that it won't. I don't think there's any object class code in the wild.
We don't expect to be... Sorry.
Yeah, I think the Lua code is just do the calculation, so it's not likely blocking.
The Lua code? No, the Lua actually, I think what they did was they crammed the object class API up into a Lua thing. And that's actually easy. If you know anything about the Lua virtual machine, you can actually suspend a running Lua thread because it doesn't have a real stack, return out of it, and recrystallize it later. It's no problem. Lua has first-class coroutines, and they're accessible in the C API you use to embed the VM. Basically, if you've ever looked at a game engine, this is why they use Lua. You can write plugin code or game logic code that looks like straight line code, but the game engine runs it suspended between frames, depending. It's like the whole point. So that's not a problem, and I would suggest we don't even bother to worry about it because it's MDS code, right? That's our problem later when we need to port. That'll be a fun little porting exercise, but I expect that they'll do it for themselves just for fun, right? It's not that hard, and they're a research group. So
okay.
In short, I don't think there is any C++ external code.
Okay, because there was a thread, maybe you saw it, there was a thread this week discussion that I don't remember who the client was who asked how can I do that and that, and the answer was you can use object classes.
The Nokia thread, yes, I recall that.
The other people I think who did it were CERN, but they committed them upstream. They're in the repo. CERN had some object classes. They're in the code base, but they're upstream.
So
that's the normal way of doing it.
So we should probably at some point create documents saying what we are going to offer, what is the final proposal, what is the API that we will propose.
My guess is that as this becomes more mature, we'll get sort of a beta out there with whatever's there, and then we'll start documenting that, right? Because I mean, it's like you can already run it now, right? So people who are interested in running Crimson, as we become more mature, we'll be able to go, oh, but my object class doesn't work, and then we'll deal with it then. Or we could document the API, but I don't know that we're there yet. And the other thing is, it's treated currently as an internal API, and that's probably always going to be true, because it's it's deeply mapped onto the Rados internals. In a sense, Rados is an internal API in some ways. We're willing to change it. We do maintain backwards compatibility to an extent, but it's not the same kind of handcuffs that RBD and SFFS are, right? You don't break POSIX, but we might change the semantics of a Rados call if it were wrong, for instance. We're not going to maintain bug compatibility layers, for instance. So I guess I'm saying it's a gray area. If it's a problem, we'll figure something out.
Okay, and my last comment. I'm talking a lot today. What I suggested about the error handling. You said right that you don't want to optimize. You said correctly that you don't see a reason to optimize error handling code in that PR that I commented about. The only reason I suggested it because it reduces. It was in the right direction regarding exceptions, which is minimizing exceptions on regular occurrences and using error codes in there instead. So this is why I thought it might be worth a change.
Oh yes, another reason I like exception is that it embedded the error information into whatever returned by what. So it might be handy for whoever is looking at the error message, because it has materialized the error code to a command readable string. So that's why I like it without extra efforts. Otherwise, I would need to.
You would need to create a wrapped error type. Yeah.
Yeah.
I think that's what we're going to want to do eventually, but whatever. If it's what's required to get CBD working.
Okay. That's all for me.
Sam?
I didn't do much in Crimson this week. I did fix whatever that bug was last week, though, and that seems to have worked, so that's good. I did have a question that I wanted to ask at the end of the thing, so I'll defer on that one.
Sure. And Yinxin?
So the first two things is that I think that the two PRs is it's okay to merge. The first one is the perf tool. The second one is the preemptive shutdown. And
Could you post up your address in the chat window so I can take a look at it right after the meeting?
Okay, I paste it in the chat window here. Okay. And the second thing is I'm looking at the prefetching implementation and doing some evaluation I want to share here. Let me see. Can you see it?
I can.
Yep, we can see.
Okay, so it's about how to do prefetching with POSIX sockets, and it has some assumptions that we still need compatible with POSIX socket, and this implies that we will have SysCore on the I/O path, and the system core has considerable overhead, and that's why we need prefetch to help the performance, because it can read more than needed to reduce the number of system cores. And another requirement is what we are currently doing is we need to control the memory layout, like alignment and continuity, and when doing system call read, because with this we can minimize the following user space memory copy to make the correct memory layout. And that's why we have currently have these optimizations is like the input buffer factory and read exactly to either specify or hint the memory layout for read interface. And the second is what I previous is doing is adaptive prefetching. The idea is to prefetch as much as possible for the system calls. And it is the simplest way to not waste tail memory too much. Because if we just increase the prefetch size, if the actual read is not that much, all the tail memory will be wasted. And this is the simplest way. And there must be other doing things for the same purpose. And I found it is weird in my evaluation that if I'm prefetching as much as possible for smaller reads, it will be better. But for a very large read, it will be worse. So
Why is that?
so I'm evaluating the.
Why is that? Do we have a understanding why?
Yeah, that's why I have following slides to explain that. So for smaller reads, if we increase the prefetch size, it means that for each system call we can read more. For each system call, like this case, and we can for each system call we can have 14 times more size to read. It means that we have for larger prefetch size we have 1 to 14 times less system cores overhead, and that results in the better performance here. And for 4K reads, the performance the benefit is much better, because it seems we can read more data at each system call. It is now the 50 times larger sizes. It means the 15 times less system cores with 4K read, and that's why the performance is better here. But sorry,
is this test.
Sorry, I can't hear you. Sorry, Kefu, I still can't hear you.
Me too. Sorry, Kifu.
For what it's worth, we can hear you. So this is just when doing the receive call from the socket instead of just pulling what the. Oh, wait, Kifu's got a question.
Okay, Kefu's question is, was the test performed using the adaptive or fixed? It is using the adaptive for the it's prefetch up to 500K, so it is the adaptive, and this is the fixed.
I don't totally get what a fixed prefetch is.
Fixed
what if there
means
isn't 8K to read off the socket? What does it do?
Fixed is the current implementation. It always allocates 8K for each read. Yeah.
But it doesn't necessarily fill it.
Yeah, because it is very small, so it's always read 8K each time, because 8K
yes,
is
you are dividing.
What if you have an idle OSD?
Dividing big read into a series of small chunks.
Yeah, that's
very small, and each one of them gets access call.
No, I'm asking, what if you have a basically idle OSD that gets a read every couple of seconds? What does it do?
What does which do?
Okay, so if you take several seconds to fill the 8K buffer, what does that do? How does it behave? This is probably a very stupid question. I'm just not sure.
8K means the SeaStor allocate 8K memory and using system call to read to this 8K memory.
But even then, it's up to 8K,
Up to 8K.
Yeah.
Up
So
to 8K, yeah.
If there isn't that much available, it'll read less.
Up to 8K. Yeah, up to 8K. So it means in extreme cases it will read less.
So what is the difference between the fixed 8K and the prefetch up to 512K? What's the
prefetch up to 8K, it will record the last actual read size. So if the read size is the same,
so it'll adaptively change the pre-allocated buffer based on how much it got last time. Okay, that's okay.
Yes,
I get it now.
yes.
Thanks.
Okay, so this second case is still reasonable that we have better performance, but when it comes to 6K, 4K, it's different. At the first sight, the prefetch read size is still better. It comes to the 70 times larger read sizes, but the sys call is not 70 because we are using the direct read to if the prefetched buffer is used up, the rest of 6K 4K will be feed directly to the system call. So it means there are some ratio to do the direct read. So that means this ratio of memory doesn't need to be copied to make the requirement of memory layout. So what it means that
so just let me understand. What you're saying is that the problem is that we will be doing more moving of memory for the alignment for alignment reason.
Yeah, yes, the reason is because we have alignment requirement. So for prefetch, we don't know how much alignment it needs and whether it needs to be continuous. So prefetch is just reading more than we need, and if we have memory alignment requirement, we need to copy that to to the aligned memory.
Okay.
It also applies to input buffer factory because input buffer factory doesn't know what is the next message. So if it is doing
actually it knows.
What do you mean?
With input buffer factory, we are reading this. We're using the same single SeaStor. We are reading not only all segments of the current message, message epilogue, but we are also reading the next message, the next on wire frames epilogue.
Yes, the next
where we have all required
epilogue and the okay. So, but it doesn't know the next message, right?
Yep, it doesn't.
Yeah, so it's the same issue here. So, the prefetch means it reads more than needed for those requirement we are still doesn't know yet. So it means that if we find out that we actually have the memory layout, like we need some part, it needs to be aligned for 4K, and we need to copy it into 4K aligned memory space, right?
Well, if you
so
are,
for example,
we have next message coming after the next message, yes, we don't know its size.
Yeah, that's my meaning.
But we still know the next message size. So if it's smaller than, well, let's say 4K, we could switch to prefetching.
Yes.
And here adaptive prefetching could be very useful, by the way.
Yes, that's a little bit of this prefetch means we are prefetching 500K each time. That is way much larger than just 60K. So that means we are prefetching like 5 or 6. It's 8 messages size at each system core. So we are prefetching much more messages than we need in the prefetch up to 500K implementation. So it means that we need to do extra copy in this version because we may need each 64K to be 4K aligned. And that means if we prefetch too much, we may have more overhead of memory copy. So that's why that the fixed 8K prefetching it looks a little better than if we prefetch 500K, because after the prefetch 8K is consumed, it will instead use direct read to let the system call to fill up the memory of the aligned. We provided the aligned memory space, so that's why this compensates the overhead of the system calls. So that's even the same for the larger read. The larger read, the 500K prefetching is slower than the 8K prefetching because 8K only prefetch 8K each time. So most of the time it's using direct read to avoid the memory copy here. So from the metrics, I can see that there are 99% of memory are using the direct read. That doesn't need extra memory copy here. But if we prefetch too much space, like 500K, it will still have 50% memory that needs to be copied to be aligned. So that's why this is slower, and that's currently my conclusion is that we may still need prefetch to reduce the number of system calls for those small reads, like 200K reads. But if there's a large reads with layout requirement, we might better not prefetch too much. Because if we prefetch too much, we still need to copy that prefetched memory to the aligned memory ourselves. And it's kind of a paradox here. So how large is the prefetch size, the proper prefetch size? And I think it's empirical because memory copy and the system call overhead are not related and depend on the hardware and the current overhead. So I just set the different upper bound of the prefetch size, and what I found currently is that 30K prefetch size looks better, and it improved the small read performance because it reduces the number of system calls, and it also has a reasonable after it prefetches 30K, it will just stop prefetching, and the rest it will use indirect read. So this is what I'm currently finding now. And
1 second, a question.
And we can. Okay.
A question. Do we have statistics regarding the block sizes that we usually get?
I think it's 4K and 4M, right? And for RGW, and there's no fix. I'm not very.
It's dependent on the file system running on the VM running RBD, or alternately
Yes.
on the workload that is feeding RGW or SFFS. So in short, at the OSD level, given no a priori information about the workload, no, we have no idea what the input sizes will be.
Yeah,
it is, however, a typical we could expect people to set. That's possible.
Okay.
Or
Yes.
it could be a hint the client gives to the server. That's plausible, maybe. Because RBD should generally know what size it's going to send.
Okay, and another question is, another idea might be to, in whatever next version of the messenger, to add an optional field for a hint regarding forward data regarding the next or the rest of the calls that are queued.
Yes, I think
the remote messenger has so much built up it can predict in advance how much buffer the other side should. That's a good point.
True. Yes, and according to my current evaluation, there is like we can find the middle reasonable prefetch size that doesn't hurt the larger read or the smaller reads.
I mean, it looks like a pretty modest effect for anything bigger than 4K, right? It's just very small writes. It's only a win for very small writes, right? Like 4K mainly.
Like 4K, yeah, 4K. It's
even below.
Well, I don't know that we really get transfers below that, to be honest. RBD is going to typically write out a whole block. I don't think it's going to send a sub block. Although I could be wrong about that.
Yeah. So what I'm talking about is that we still need prefetch, and we don't want prefetch too much.
I agree. Yeah, and this seems like an appropriate way to set a default.
And
Yep.
Yeah, the next slide is what I'm testing the input buffer factory, and this is the current result I have for the perf Crimson Messenger from the perspective of the perf Crimson Messenger, and I haven't tested the Rados it's still work in progress. And because input buffer factory doesn't prefetch, so we can see it doesn't have very good performance for the smaller sizes. And I think that's why if we go to this direction, we still need to have prefetch feature. And set it is same problem, and we still need to set reasonable sizes. And I still don't know why this seems the prefetch the read exactly 2 version seems a little faster than input buffer factory with larger read. Maybe
Just posted my evaluation. Here is the GIS link.
maybe sorry, Doc.
I posted a link to the evaluation from a Crimson having buff modification to SeaStor to itself related to buffer into buffer factory. Link
Yes.
should be in the chat.
Yes, it's Riddle's bench, right? I still need to test it, but this is the perspective of the perf Crimson Messenger without the payload, the OSD payload. So it's simpler and reflect more from the perspective of the messenger part because it has no payload of the OSD. So maybe the result can be different. So that's why I still need to try Riddle's bench.
Yep, employing Raiders bench seems reasonable. However, what is also worth a point is that my testing was on Crimson OSD with writes in CN stored bypassed. So it's focused almost entirely on the messenger part.
Yeah, I will try to find out the overhead introduced by OSD backhand. So if we read doing the same test for the perf Crimson Messenger and the same test for the Riddles, and we can find the overhead of the OSD by the difference of the performance result. So for example, if we are doing the same 4K write to perf Crimson Messenger and the Riddles bench, and the result is different, and then we can tell how much overhead is introduced by the OSD part, right?
Yeah.
I think it would be more interesting if we can mimic the behavior of a BlueStore by adding a step to flatten the memory chunks to force it to be 4K aligned. If it's not, that would be more interesting, and it's more realistic.
Sorry, if you could repeat, please. I got a network glitch. Sorry.
I think it would be more interesting if we could introduce the step in SeaStor to mimic the behavior of a BlueStore, to try to align the memory chunks if it's not already 4K aligned. That would be more realistic.
I see. In the testing, in the GIST, memory chunks were aligned to 4K.
Yes, that's a nice thing of your input buffer factory, because it's help to reduce the overhead of alignment. But currently we don't enforce the alignment in SeaStor.
I
Yep,
think
William.
Riddle has assumption that the OSD part has very little overhead when doing Riddle's bench. So I'm thinking of if we can evaluate the overhead from the OSD layer by doing to compare the result of a perf chromosome messenger and the Riddle's bench, because the difference of these two perf tools are Riddle's bench has OSD backed, and the perf chromosome is not backed by OSD.
Agree.
Okay.
Last comment, if I may. One about the assumptions presented at the very beginning of the slides. I'm not sure, and I'm not entirely sure that having a syscall in POSIX while using the POSIX stack, while using the kernel networking, is inevitable. I'm pretty sure that introducing IOU-ring to SeaStor will neglect the need for prefetching.
Yes,
That's one.
Yes,
That's the
why
reason why I'm.
Yeah, that's why I put the scopes here. That there's assumption that we still need to be compatible with POSIX socket, because
yes, but
yes,
well,
it's
IOU-ring will be
entirely under the
compatible with
scope.
POSIX socket. It will be, I believe.
And
it's
if
just a way.
A different way of interacting with the same network stack, right?
Exactly.
So it is compatible.
The problem will be disappear because IOU-ring will not have system call on the IO path. So I think this entire issue will be gone with IOU-ring.
Makes sense.
Yep. And when we in Barcelona, we were talking with Ilya Droimov, who is our kernel developer focused on KRBD, and he's pretty sure that IOU-ring will be backported to old kernels, to old HAs. So that's one of the reasons why. Okay. Input buffer factory actually can do prefetching, can do even adaptive prefetching, and even something more complicated because it has access to more knowledge, application-specific knowledge. But to be honest, I would love to bring IOU-ring implementation to SeaStor instead of investing a lot of effort in doing prefetching for legacy things. I bet the syscall, the interacting with using syscall will become legacy very soon.
Mm-hmm.
I agree.
I agree. I think adding prefetch is not very big.
It's complex.
It's complex.
It's pretty complex. You are doing extra work just for the sake of avoiding even costlier work. I mean syscall. If you get rid of syscall, you are getting rid of the problem.
But currently we only have POSIX socket. We don't have any other solutions available right now.
Well, the support team for IOU-ring is available since 5.
I was going to say, I think it's worth pointing out that Crimson won't be ready for production for some time. So if the assumption is that IOU-ring is going to be backported, then we can just assume that it will be, and do our development on that basis. Does that make sense?
But we need
We
to
would just have to use
already,
slightly more cutting-edge kernels in the meantime.
Yeah, I think
Which is
if
irritating.
the assumption is, if the assumption is holds, we need to ready the testbed to show the performance result like 1 year after. So we need to deploy a kernel like 5.0 or up in the testbed. We perform the test performance test.
I mean, that seems like a reasonable ask.
Yeah.
So the conclusion that we can accept not doing prefetch with POSIX sockets, right?
Well, I don't know if it's a conclusion, but the point for discussion is maybe we just don't worry about the prefetch overhead for now, or the extra syscall overhead for now, because we just assume that in a month or two, we'll take the time to set up test beds that have IOU ring and begin migrating to that instead.
Okay.
That is a thing that could happen. Or we could invest time in getting prefetching working. Those are the options on the table.
I would vote for waiting for IOU ring.
But if IOU ring is faster anyway, and that's likely to be where we'll want to go, then arguably the prefetching is just extra work.
Mm-hmm.
Does that seem like a fair statement of the problem?
I think another way to go is probably make it the compile time option to enable prefetch or not, and make it an option at the compile time. Yeah, and in the worst case, we still live with need to live with and kernel without IOU support. In that case, we just need to tweak the option and enable the prefetch, because we have a prefetch as a fallback.
Yeah, I think prefetch is a side effect of the current POSIX socket implementation. If we don't really think this is very important, we can, yes.
But we need to update the SeaStor to enable the prefetching, namely adaptive prefetching, right?
Well, that's one of the things the buffer factory tries to do. It delegates the responsibility to determine the size of your prefetching buffer to application. And the reading exactly the message size is basically some kind of special case of doing the prefetching that basically neglected.
So prefetching is basically a policy could be supported by input buffer factory.
Exactly. It's whether you want to do fixed prefetching, whether you want to adaptive and very crazy adaptive prefetching is up to application. That's the advantage of buffer factory, flexibility to application. It's not only about doing alignment at the beginning, alignment in the middle, alignment according to the end of buffer. It's just delegating the memory layout, including the buffer size, to application.
So I think probably the plan is to let's wait until the input buffer factory is merged by CLDB upstream, and then we can adapt the prefetching policy to input buffer factory and enable it as probably as a compile time option. What about it?
Or a config option.
Yeah.
I think so.
I had one just in the last 10 minutes. Has there been any thought put into what it would mean to run Crimson with less than one core? That is, on a machine where you expect to share the core with other work because you expect the OSD to be largely idle. How does SeaStor behave in a situation like that?
You mean a reactor want to have the full access of a core, and it will share a core with another application, like.
And in particular, we would like it to not be a jerk about it. We would like it to go to sleep when it doesn't have work to do. Is that a thing, or is that something we would have to add to SeaStor?
I don't think SeaStor has such kind of enforcement.
Not enforcement. It's just that right now, I believe it never goes to sleep. It pulls. We just need it to not do that. Okay, so this is something we'd have to add.
I don't think
Can you
we
repeat?
need to
Can you
do
repeat?
anything.
So one of the assumptions underlying the way we've been talking about Crimson so far is that some subset of the cores in the machine will be simply dedicated to running an OSD, regardless of how we choose to do the sharding. That's just true, right? So because of that assumption, SeaStor does some things. Like it doesn't really go to sleep. It just assumes that if at the moment it doesn't have work to do, it's too expensive latency-wise to go to sleep. Because if an IO comes in, it'll take too long to wake back up, right? So it pulls. But there are environments where we would like to be able to run in the same box with other applications, and the expectation of the storage stack is that it will be lightly utilized, if at all, most of the time. So this isn't a performance situation. This is we've replaced classic OSD with Crimson OSD, and we want it to scale down the same way. Telcos do this.
How costly would it be to keep the existing behavior, which means that you do monopolize a core for Crimson?
Potentially too expensive. That there are not that many environments. Like what you're probably thinking of is like a cloud kind of environment where you're serving VMs and stuff. Think more like you're at an edge node at a telco that's serving edge content, and you're running Ceph mainly because that's the platform you've chosen, and it does a good job of serving RBD and RGW, but it's only to like 2 nodes, right? And there's other stuff running on the boxes, and you simply can't dedicate, from a cost point of view, a whole Xeon core to one OSD. Too expensive. So there are real life situations where this does happen today.
And you're willing to pay the latency price, the
Yes,
latency
yes,
cost
yes, yes,
for
yes,
that.
yes. This isn't a performance thing. This is a cost and uniformity thing. So by the time they've made this choice, they've already written off like their latency goals. It's going to be slower. That's fine. I'm asking, is there a mode like that for SeaStor?
I think it's okay-ish, as long as the latency won't be noticed by the reactor. Like the core won't be blocked for too long by the thread used by another thread, by another application.
Well, that's the trouble. If it always pulls and never goes to sleep, from the kernel's point of view, the Crimson OSD is always busy, right? That's bad for 2 reasons.
As long as there's some task in the queue, it's already busy.
But if there isn't, it'll go to sleep?
Yes.
Okay, good. Cool.
But the situation can be where your OSD is partially filled with requests, and there is no sleep between those rare requests. You have some busy waiting.
That's okay.
Yes.
As long as we can control or sort of configure the kind of busy waiting, right? Like as long as it's like an exponential back off kind of busy wait, and it has some concept of trading off between burning CPU to save latency and going to sleep because watts are watts, right? Okay, cool.
Okay, I see.
There's a grace period before it's going to sleep.
That makes sense. Okay, cool. In that case, it doesn't sound like it's a problem at all. It'll just go to sleep, and that's fine.
I think I have tested it to bring up one messenger server to one core and 2 messenger client to another 2 cores, and it makes one server core to 100% busy, and the 2 client cores not busy that much. It doesn't reach 100%. It looks like 60.
Well, that's what you'd expect, right? The client does less work per IO than the server does.
Yeah, so it doesn't consume all the CPUs on
not all the CPUs,
core.
but right now with Crimson, it consumes at most one core, right? I'm just asking if you turn those 2 clients off, the OSD will stop consuming CPU, right?
Yeah, yes.
Okay, cool.
Of course.
Cool.
Any questions? Okay. See you next week. Have a good day and have a good night.
Bye.
See you. Good day.
Yeah.
Bye.
See you, folks. Bye.